Hello, everyone. Welcome to Behavioral Health Lesson 9. Today, we'll be talking about the organization of long term memory in the mind. Our understanding of memory is in various facets, whereas we don't have that much of an understanding of non declarative memory organization. We have a much better understanding of declarative memory and, in particular, semantic memory. Now, both semantic and episodic memories follow similar principles of organization, and memories with shared characteristics are more closely linked. Now, what do I mean by this? So, if you're going to multiple places, for example, you go to a shop, you go to the clinic, or you go to an amusement park, and you're in a car. Well, when you think of this common theme of a car, you'll likely think about all three of these memories, or if you think of one of those memories of going to a shop because of the common theme of the car, you will also make a link in your brain with the amusement park and the clinic. Let's give you an introduction to connectionist theories. Connectionism is this idea that the mind is an interconnected system made up of similar units. Now, this computer scientist named Killen, while he was trying to get a computer to understand the English language, he inadvertently created this explanation or this model of how humans organize things in their mind, which is called a hierarchy of concepts. For example, living animals include general things like birds, fishes, etc., right? And then for each of those particular categories, we might have various items in those categories, and we can give those categories some traits. For example, birds have wings, and some birds include canaries and ostriches, and fish, for example, have fins. That includes salmon. Now, thinking about one thing will lead to thinking about related concepts. So, if you think about one type of fish, you might think of another type of fish as well. Now, the spreading activation model is an amendment on the hierarchy of concepts. It was modified by Quillen with a scientist called Loftus. Now, people don't necessarily use strict hierarchies that are predetermined from birth to organize concepts, right? We form our own organizations based on our personal experiences. So, concepts and properties differ in the strength of their connections. Now, this also explains the lexical decision experiments which demonstrated priming in the last lesson. For example, if you show two words which are real and those two words are unrelated, there is no previous link in the mind when you already see the first word. However, if you show two words which are related, like doctor and nurse, as you're looking at the word doctor, your mind has already made the link with the word nurse, which will make you pair them up quicker, which will make your mind confirm quicker that both words are real, which is why real words that are related will have a faster reaction time than words which are unrelated. And this is a visual diagram of the spreading activation model. So, for example, if you think about red, you'll activate nearby concepts like orange, green, which are other colors, and fire. And because those are more closely linked, then you'll think about those faster than more distant concepts like sunsets and roses, which are red. This network suggests that a person would answer the question, is a bus a vehicle, faster than the question, is an ambulance a vehicle? Inferences using schemas. So, this guy called Frederick Barlett did an experiment where he would read long, involved stories to participants and ask them to remember it and then retell the story. Not only would the participants simplify the stories when they were retelling it, but they would also add their own aspects to the story. It was, and those aspects were not nonsensical. These aspects made sense, but they came seemingly out of the blue. Now, what can we conclude from this? Well, memory storage does not exist in a vacuum. We attempt to fit new information into a schema, a set of expectations about objects and situations. This is a definition that you will definitely have to remember. An example of a schema is a stereotype. Now, details consistent with schemas, for example, paintbrushes in an artist studio, are more easily retained, and vice versa. For example, if you walk into your English teacher's office and you see a pile of books, and then you also see an image of the teacher's farm, well, what fits the schema of an English teacher's office better? The pile of books, right? So it's much harder to remember the photo of the farm in your English teacher's office, and more so, you'll remember the pile of books. Schemas are very important in the process of memory storage as well. For example, if you quickly take a look at this passage and try to make sense of it, and then try to retell it, well, you'll probably struggle a lot because you don't even know what the passage is about, and you'd make a good point. However, if I now tell you that it's about doing laundry, then you'll be able to remember the content easier. You'll be able to take in the content easier and then remember it easily. So, essentially, the takeaway is that when you've fitted all of your information into a schema, then you'll be able to recall it easier. The self is the most important schema. Information is most easily stored if it's reflected in your personal experiences. There are two types of memory retrieval: short term and long term. For short term, imagine a situation where you have to recall 5 letters for a subsequent test, and I'm telling you that you will be tested on these letters subsequently. The test is to pull the yes lever if a letter is shined at you and the letter is part of that list, and vice versa, as fast as you can. There will also be a no lever. Now, Sternberg's experiment was to do this test for a 1 letter series to 5 letters, and each new letter in the list made a reaction time increase by 38 milliseconds. So 38 milliseconds slower to confirm whether a letter was in the list, the longer the list was. The conclusion is that while we might think that we're just automatically going through all 5 items in our short term memory instantly, we're actually doing it one at a time, right? So when you're confirming whether, for example, K is in the series of letters, your mind is actually going through the letters C, A, F, H, K in a stepwise order. Now, for long term memory, there is a significant impact for cues. Cues are very important. And cues are any stimulus that helps access target info. This is why true or false questions and matching questions on a test are easy. The information is literally in front of you, and you just have to decide how well each piece of information matches what is stored in your memory already. It's also why recognition and essays are harder because you must know what information to retrieve it, know for sure that the information is correct, and then proceed. So you have less cues given to you. Now, personally generated cues are better than cues other people give to you. For example, if you're asked to memorize 600 words, which was an experiment done previously, if for every single word you are given 3 synonyms or other cues by other people, you will have a success rate of about 55% when you're trying to recall. However, if for every single word you yourself determine what other synonyms and cues you want to use to remember those words, you will have a very high success rate of 90%. Encoding specificity is this concept that our memories incorporate unique combinations of bits of information when encoded, even when these are not, even when this is not the target information, right? There's a bunch of things which are also going to be encoded Now, any stimulus noticed during this encoding process could serve as a cue, and more cues aid retrieval. It's more successful when conditions match the original encoding. And it explains why retracing steps and actually physically being in an environment where where you've lost an item can help you with recall because it reactivates associated cues. Realize that when you're encoding target information, you're also encoding the bits of related information, as I said before, including information about the environment. This explains why you should study in a well lit environment with no distractions. This will be similar to an environment which you are tested in. Context dependent memory also helps with implicit memory, specifically procedures. For example, if you are learning to fly an airplane, you'll be much better off doing a simulation rather than just remembering things by the book. Physiological states also help. If you take caffeine while studying, then you should probably have then your most ideal test taking uh, environment would be having caffeine in your system and vice versa. If you haven't had caffeine, then you should try to then caffeine ought not to be in your system when you're taking the test. This can be even more extreme with other types of substances. Now, cognitive states will also have an impact. For example, for bipolar patients, we can take a look at emotion. For example, if you have mania when you've encoded something, you will have an easier time remembering this thing when you are in a maniac state, mania stage. Whereas if you encoded something when you were in a depressive state, you will struggle with retrieving happy thoughts and you will have an easier time retrieving depressive thoughts. Language is also related, right? For example, they observed Russian immigrants in America who could both speak Russian and English. If they encoded a memory in their minds while using Russian, then it would be much easier to use Russian. Uh, it would be much easier to recall the memory if they were using Russian at the time rather than English for episodic memories, right? So the language used to recall the memories mattered. Achievement motivation is also related. If you read a book about a highly motivated individual, you will easily recall details from the story of your highly motivated yourself, and vice versa. If they don't match, then it will be more challenging. Tip of the tongue is a phenomenon that explains this statement, this claim that retrieval is a step-by-step process that brings you closer to the target. For example, if you are given a definition of a word like sextant, you will probably have a hard time trying to recall the word because even if you have been exposed to the word before, it's probably been a while and you've probably not had to use the word in a long time. Most participants were able to partially recall the word, right? They might have been able to identify the first letter of the word given the definition, the number of syllables in the word, and words with similar sounds. Now, the last one is interesting because this could either block the ability to retrieve the actual word, or it served as as an auditory cue that got them closer to the actual word, sextant. Now, reconstruction during retrieval, right? But this means that your long term memory has to work in tandem with your working memory. The mind reconstructs the memory and combines retrieved content with info that's already in your working memory. And once that's activated, it's going to interact with other things in the working memory and re encode it into a new long term memory. And this explains things like why like the adventures of King Arthur are so distorted now. We actually have no idea. We have minimal idea about what the original stories were about because the audience, each new generation, is going to focus and highlight details that made a lasting impression on themselves. Now, also, for example, if I show you a video of a car collision, a minor collision, there's no glass shattering, right? And then after a while, I ask you, hey Joe, in that video that you saw, Did the cars hit each other, right? About how fast were the cars going when they hit each other, whereas the second group was asked about how fast were the cars going when they smashed each other. If I ask you those two questions, or one of those questions, you'll definitely remember some details about the accident. However, if you heard the word hit, you might not think that there was glass on the road, and you would be right. However, because smashing each other is more violent, you might imagine there have being glass shattered on the road. Now, there's two possible explanations for this after the fact, right? The memories of the cars colliding and the no glass being on the road and glass being on the road could either coexist, or the new one of glass being on the road, in the case where I ask the question if the cars smashed into each other, overrides the old one. Experimentally, it probably is the second one because it's very difficult to retrieve the original memory. So it does support the overriding hypothesis better. Now, the fuzzy trace theory is the fact that we use our memory resources to our advantage. We use precious resources to form different types of memories based on our needs, ranging from verbatim or exact accounts to gist, which means we retain the general idea of events. Now, gist can lead to false memories. Interestingly, the use of gist increases with age. If a young child went to a birthday party that was Harry Potter themed, and then I ask them, well, what happened during the party? They will struggle to use the theme to provide gist accounts of events that happen, whereas an older individual would be able to use the theme of Harry Potter to remind them of Harry Potter related events that happened during the birthday party. Source monitoring helps with the accuracy of helps measure the accuracy of memory. Under normal circumstances, we do a good job of distinguishing between external and internal sources of information. But we can also produce false memories when we attribute a memory to the wrong source. For example, if I remind myself to tell my roommate that I'm going to be coming in late, and then my roommate asks me, why are you so late? You might be shocked. You might say, wait, didn't I tell you already? Right? This is where you're mistaking the source of the information, right? You think it's external, but it's actually internal. Now, fantasies versus reality. I find this quite interesting, and it's related to neuroscience. It's related to brain parts that you already know, actually. The brain activates episodic memory for real events and semantic memory areas for fantasies. False memories may arise from confusion between these activation patterns, making fantasies seem real. Realistic situations trigger the prefrontal cortex for episodic processing, whereas fantasies trigger the semantic processing areas that we learned earlier. However, if fantasies trigger the prefrontal cortex or reality triggers semantic processing areas, you could get confused between the two. With the retrieval of emotional events, emotional moments are very easily stored in memory. Emotion provides quick guidance for approach avoidance decisions, and forming memories of these situations help us respond appropriately in the future to similar situations. This makes sense, right? It's evolutionarily beneficial to us. But we can also have things like motivated forgetting, which are where bad emotions make it harder to recall a thing. Flashbulb memories, where a very vivid memory of a traumatizing or emotionally impactful event helps us remember many, many details. PTSD individuals, on the other hand, get intrusive flashbacks. But notice how all of these things are kind of inconsistent, because whereas motivated forgetting is where a very emotional, where high emotion memories um, make you forget the thing easier, flashbulb memories help you memorize the event and help you recall it better, even if you don't want to. So, how do you explain this? Well, recall that the hippocampus forms new declarative memories, and the amygdala helps us assess emotional situations. Let's take a bizarre but real case study where we can observe both of these things. If you get buried in sand, you will have a lack of oxygen, so your hippocampus will not work. The effect is that you're constantly fearful because whereas your amygdala is activated, you don't know why you're fearful, right? You're traumatized night and day, but you don't know what you're traumatized by. And it's the opposite for those with an intact hippocampus and a detached amygdala. You'll have a good memory for non emotional details, but no enhanced memory for emotional things. Flashbulb memories are very clear because the amygdala is working very hard. While people are often overconfident about the accuracy of their flashbulb memories, they do kind of have a point. Retrieval is indeed more accurate than other types of memories made during a similar time of day, which were more mundane and boring. Now, sudden stress makes the prefrontal cortex less effective, right? Less action, and it impairs memory function. But cortisol in blood, which is also caused by stress, means there's more activity in the amygdala, which creates more emotional impacts, which creates more false memories. Now, forgetting is the fact that memory is formed and then it becomes harder and harder to remember. Not paying attention in class, though, is not forgetting. You just failed to encode in the first place. You were not paying attention. So, when we use the word forget in real life, we tend to use it in a more general form. However, we're specifically talking about how the memory has already been formed. Injury or disease caused forgetting is called amnesia, and on the next slide, we'll learn about decay, which is another type of forgetting. Now, it's hard to understand because forgetting is measured through actual performance, which can be influenced by factors like stress or illness and distractions. But when we talk about forgetting, we're ignoring all of these details. We're ignoring forgetting that happens because of these factors. And forgetting actually has adaptive benefits. We prioritize things that we should remember. Thankfully, we don't always remember our old passwords that we've already replaced with new ones. Otherwise, every time we sign in into a new website, we'd have to figure out first which password is obsolete and which one is the one we should use. Now, fMRI scans, which measure the activity in the brain, proves that the prefrontal cortex actively suppresses lesser used memories in order to avoid confusion and reduce the work needed to recall higher stake information. Now, decay is the ability to retrieve information we do not use and that fades over time. And just because you cannot ace your exams anymore from last semester, it doesn't mean the memory of all the things you've learned is permanently lost. For example, if I ask you to learn and memorize the entire periodic table, it might take you 50 trials right now. And then you forget it. In an ideal world, and then I ask you to forget about it, never touch chemistry again for 2 years. The next time you learn it, when you're in grade 12, or 2 years after today, let's say, it might take you less trials with the same cognitive function. Right? You definitely save some prior memory of the table because your brain is not suddenly becoming more effective. And this is the method of savings to demonstrate that the memory is definitely still there. It's just harder to retrieve. Forgetting is not just because of decay, though. There are probably more reasons. Now, interference is the competition between new and old information. The brain takes time to consolidate a memory and produce a physical representation of it, and the window of time that's used for that allows room for distortion, loss, and replacement. Now, the synaptic length of the synaptic consolidation length is about a few minutes to a few hours, right? Which is why I take head trauma patients who get unconscious. They'll often forget how they got into the situation in the first place, and the same can be said for anesthesia or people who've gone through electroconvulsive shock therapies, which interfere with their neural transmissions. That produces a memory deficit, often of a couple of days as well. Now, storage of memories in the cerebral cortex can take years, so the information can be lost and distorted in that case as well. Now, when we learn more and more lists of words, do we truly forget the first list? Is it truly erased from our memory? Well, no. If you give a cue about what the first list of words was about, the effect of interference is revealed to be quite small, which also demonstrates that the information is still there in your memory. It's just making it harder to retrieve. Now, there's two types of interference, right? If you've procrastinated for a French quiz, let's say, and you have to memorize three lists of vocabulary, the fact that you have to memorize the first list will make the recall of the second list more challenging. This is proactive interference. Now, retroactive interference is the opposite, where new information interferes with recalling older information. Motivated forgetting is a failure to remember threatening or unpleasant info, which is also evolutionarily sensible. Memory is a servant to our goals. For better or worse, retrieval is affected by our motivations. Motivated distortions of memory can become so extreme that the original information seems to be lost. Let's say you make a difficult choice, right? And you have two options with both the same amount of benefits and downsides. You ultimately remember more benefits to the option you chose, even if someone else convinces you that you actually chose the other option. Your mind will not be changed. You'll still remember the positives of the choice that you actually did select. People also often forget ethical rules after they are provided an opportunity to cheat. They justify themselves by forgetting those ethical rules. Discrepancy between behavior and attitude can often change the attitude itself, and we easily remember things that are simply not true at times thanks to this. And false memories are actually rather easy to implant. At the synapse level, forming new memories requires change in neural connections, a process called synaptic consolidation. This guy called Eric Kennel did some research on sea slugs, which demonstrates that learning leads to persistent changes in synaptic strength, including stuff like classical conditioning. Learning also triggers changes in the gene expression, which results in long term structural changes in the neurons, which create long term memory. Sensitization increases the number of axon terminals, right, which creates more responses, and vice versa. Long-term potentiation is a persistent increase in synaptic strength following a high-frequency stimulation of a chemical synapse, which can be demonstrated by applying a rapid series of electric pulses to one area of the nervous system and then observing the increased reaction of cells receiving information from that area, which is demonstrated on the next slide. Now, there's the biochemical relation between for memory. We'll learn about ACH, which is a neurotransmitter, and it inhibits and drugs that inhibit ACH impair memory. Right, same for Alzheimer's patients, and it can be observed in bees as well when they're trying to remember the positions of the flowers they pollinated. Turns out if you just give them ACH, the neural changes will be the same. Now, glutamate, particularly NMDA receptors, are also responsible for memory formation and long term potentiation. Chemicals that enhance glutamate receptors improve memories in rats and are being explored for Alzheimer's treatment currently. Now, how do we improve our memories? Well, first, you can distribute your practice over time. You can take tests, which can form superior long term memories than just plain studying and rehearsal. Sleep reorganizes existing memories to accommodate new information, right? And REM improves retention of highly emotional material. Recitation is better than plain rehearsal because you're putting information into your own words, which makes it more relevant to yourself, linking to the personal schema of the self. And mnemonics helps with recall. And you can also use the method of loci, which is where you visualize each item in a list in a familiar location, like your childhood home. All right, so, our quick recap, we've learned about decay, interference, and motivated forgetting. Thank you for watching this video lesson. If you have any questions, please leave them in the comments below. And I hope you enjoy your studying as you prepare for the SLC, which is coming up soon. Good luck, and thanks.